Rinnai, New Zealand. I'm Alice, Specification Manager from Rinnai, and your host and moderator. Thank you for taking the time to join us today as we talk about indoor wood burners. While we're waiting for everyone to arrive into the room, let's test our chat function by typing our answers for this question. Your comfort food in winter. Again, what's your comfort food in winter? Please type your answers in the chat. And while we're waiting, I thought I would share a recipe. It's called Creamy Crock Pot Hot Chocolate. It received 4.24 stars from over 1,300 reviews. It's perfect for parties, special occasions, midwinter gathering, or chats by fireplace. You can also swap ingredients with plant-based alternatives. Let's have a look at the chats. Oh, laksa is definitely one of my favorites. And curry, roast, very nice. Soup is definitely top of the list. Oh, thank you all for sharing your answers and good to know that chat is working. Let's start. Welcome to today's CPD webinar brought to you by Rinnai, New Zealand. I'm Alice, National Specification Manager from Rinnai, your host and moderator. Thank you for taking the time to join us today as we talk about a hot topic in winter, indoor wood burners. This is part one of the wood burner series we're running. This webinar aims to assist architects and specifiers to gain a better understanding on indoor wood burners and specification information. Today's format will be 40 minutes of presentation, followed by Q&A with 10 NZROB CPD points. For smooth running of the presentation, we kindly ask you to submit your questions in the Q&A section, please, and we'll answer them during Q&A time. Again, please type your questions in the Q&A section, and we'll answer them during Q&A time. If you have joined us via Teams web format and may not have all the functionalities or simply too shy to ask questions publicly, don't worry, we'll have our contact details at the end for you to send questions through privately. Let's start with a 1-minute introduction about Rinnai. Rinnai has been in New Zealand for over 45 years and is located in Auckland. With over 1 million appliances installed into Kiwi homes and businesses, Rinnai New Zealand has established a proud reputation for quality and reliability. Rinnai's mission is creating a sustainable, healthy, comfortable way of living. We provide a range of products and services that cover climate control and water heating solutions. For water heating, Rinnai has gas infinities, hot water cylinders, hot water heat pump, and commercial solutions. For climate control, we have heat pumps, gas central heating, gas fireplaces, electric fireplaces, and Warmington wood burners. Rinnai acquired Warmington brand and FireSpy design in August 2023. Warmington has been building fireplaces for Kiwi homes since 1994 and continue to remain committed to delivering high-quality products into New Zealand homes. Warmington fires are built in our factory in Auckland by a highly skilled team backed by our team of engineers and accredited in-house IANZ test lab to ensure all of our products are built to the highest standards. Now, without further ado, it is my pleasure to introduce our speaker for today, Rachel Derrick. With 2 decades of experience in the building industry, Rachel has encompassed roles ranging from lighting design and sales to architectural draftsmanship, project management, and quantity surveying. Currently serving as sales and technical support at Rinnai, Rachel collaborates daily with architects, engineers, and installers, providing crucial assistance in technical requirements, building code compliance, and design markups. Rachel had been with Warmington Fires for 8 years before joining Rinnai, where she developed a deep understanding and expertise in these areas. Over to you, Rach.
Thanks, Alice. Hi everyone. Today's topics we will be covering: advantages of wood burners, why you would have one, and the benefits and advantages of them, types of indoor wood burners and slow combustion fires, how they work, combustion air, new builds, ventilation, and inbuilt models, NES regulations, clean air requirements, how to find the information in the ECAN list, safety clearance testing, what happens, why is it done, all appliances are safety tested, how are they tested and why, installation requirements, why we use these and when. We will go through heat shields, flue terminals, downdraft and negative pressure around design and layouts. Wetbacks, what and how to size them, and hot water cylinder information and links sent out at the end to the Rinnai website. General maintenance and insurance requirements, warranty requirements and chimney fires, NZHHA and support from Warmington available. Why choose a wood burner? There is more heat output than a gas fireplace. Heat outputs of wood fires range from 6 kilowatts right up to 35 kilowatts. You can cook on or in them. Water heating options available in a range of sizes. Cheaper source of heating. Wood is a renewable resource in New Zealand. Efficient and eco-friendly way to heat your home. Different sizes available to suit any size home. We use a rough guide of 1 kilowatt of heat output to a 10 square meters of floor area when sizing a wood burner for a home. It is not reliant on power, great for off-grid installations or unreliable power in New Zealand. There is a wood burner available for every part of New Zealand. We have three main types of wood burners on the market in New Zealand. Open wood fires with no door on them, either a steel firebox like a Wilmington SI indoor range, or the traditional bricked fire range, and slow combustion inbuilt fires with doors on them, example, the Wilmington Evoque. Slow combustion wood burners. The third main type of wood burner is the slow combustion freestanding wood burner. Examples shown are the Wilmington Tasman, the Southern Series fires in a range of sizes and oven option, studio stove and oven with coloured options available, and the newest, the Studio Compact series in three different versions, pedestal, log box and wall mount available. Some of these options will be NES approved, some won't be, and you will need to check with the manufacturer for these. How to choose the right wood burner. There are many different aspects to choosing the right wood burner for your project. What is the site requirements and what are they allowed to have? Example, are they in the clean air shed? As this will determine the choice of fire they can have. If they are, we move straight to the approved wood burner list. If not, have they got 2 hectares? If they have, they can have any fire they like. Then we move on to what is the purpose of the fire. Is it the only source of heating? Are they needing to cook on it or in it? Are they heating water with it? What size do you need? This will mostly be answered by the second question, alongside doing your H1 calculations for the building and understand your client's heating requirements. What type of look does the client want? Some clients will have a very specific look. They might want right from the start, e.g. a steel or bricked fire. Do they want a large flame window or a small window? Then once determining the above, we will have a very clear idea of what fire they want and how and what we can offer and the accessories to go with it. Example, gas starters for open wood fires, wetbacks, spark guards, etc. How does a Wilmington wood burner work? The diagram shows the basic principle of how a slow combustion fireplace works by turning the three main components for fire into heat. For a fire to operate correctly and efficiently, you need oxygen, fuel, and heat at the correct ratio to work. Wood burners take oxygen from within the room, and you can control this through the damper on the front of the fireplace. Combustion air also enters through a preheated secondary inlet to provide the correct mix for optimum combustion. Combustion flue gases are released up the flue after the gases have been redirected back through the fire bed by the secondary air. This process produces clean, efficient heating. How does a wood burner heat the room? By allowing the cold air in the room to travel up the side of the firebox and into the room. Most freestanding appliances use this method. An inbuilt fireplace works in two different ways to get its combustion air. Wilmington open wood fireplaces require external air to feed them. It is extremely important in newer homes due to how airtight they are and mechanical ventilation systems installed, which affect the combustion air inside the houses. Wilmington fires take almost all of their combustion air through the KTEX system, which means you will not get backdrafting into the room or spilling into the room. Some combustion air comes from the room when the fire is first lit, but to keep an open wood fireplace going well, you will need to be able to supply it with combustion air somehow from outside. When you are putting in an open wood fireplace in the middle of the house, we recommend running 2 times 100 diameter plumbing pipes in the slab to the outside air before the slab is poured. This is the easiest method for getting the external cold air into the firebox, and where it terminates outside, you will just need to have it covered with some vermin-proof mesh. If your fireplace is situated on an external wall, you can have the vents directly from the back of the firebox to outside and use something like a subfloor vent to cover the holes, being aware not to decrease the volume of air required, which is 2 times 100 diameter vents or equivalent volume. The vents need to be as close as possible to the base of the firebox for the firebox to be able to pull in the combustion air. The vents also provide the cooling air to the cavity, which is required for the tested installation to keep the cavity cold. Air pressure. This is a common problem we are seeing in new builds. When we have positive air pressure in the home, the fireplace will work well. If we have a situation where the home has negative air pressure, the fire will suffocate and go out, or smoke back into the room. This will become much worse when any form of extract unit is turned on in the house. We need to balance the house and get the air pressure correct at the design stage of the building. With airtight homes and large extraction units in bedrooms and kitchens, we need to consider the effect this will have on the fireplace. An open wood fireplace can use up to 22 cubic meters of combustion air per kilowatt of heat per minute. Clean air regulations. Slow combustion, as you will be aware in New Zealand, we have an air pollution problem. And one way the government has chosen to address this is through the regulation of wood burning appliances. In New Zealand, all properties that wish to install a wood burning appliance within a designated clean air shed need to comply with the NES regulations as a minimum. In 2005, the NES introduced the Clean Air Regulations together with 2 new standards, AS NZS 4012 and 4013. Each council can set their own limits that are stricter than the NES regulations but aren't more lenient. As you can see by the graph, It is defined by two areas: rural, which means the property is outside the clean air shed and has 2 hectares of land or more, and urban, which means the property is within the clean air shed and has less than 2 hectares of land. You can see there are some exemptions to these rules on the right-hand side, but once again, you will need to check with the council for each site to confirm their requirements. Other exemptions to this rule are properties that are heritage listed. Fireplace examples. Examples of ULEB fireplaces, which are ultra low emission burners. Clean air approved fireplaces in your urban areas. And rural fireplace. This is a view of what you will see when you use the eCan Clean Air Shed online tool. You can type in the site address and it will display the site. And if it is within the clean air shed, you will see the blue bubble over it as shown. This is the first step in checking to see what the requirements are for a site. Some councils have imposed more stringent rules requiring ULEB appliances. You will need to check each council's requirements for each build you are working on. Why do we have clearance testing in New Zealand? The purpose of the clearance test is to have a regulated standard for wood fireplaces to be installed into buildings. This test establishes that the appliance will not reach over a maximum temperature allowed for combustible materials. Therefore, the appliance can be installed safely. Once we carry out the testing, that data is recorded and therefore builds the clearance requirements in which we publish in our specifications. 2918 is the safety document we carry out the testing to. As you can see on the drawing, Warmington clearly state the clearances required to combustible materials. If you wanted to install a fireplace closer than shown, you will need to default to the heat shield requirements. We will come to this soon. The manufacturer cannot issue any other documentation outside of this to say your installation complies, typically. They might help you to show compliance with 2918 though. If you're in a situation where you cannot achieve these clearances as shown on the specifications, we would recommend you contact the manufacturer directly to get assistance in your design. Safety testing and how the appliance is tested. The current standard we're using is AS NZS 2918 2001. There has been a new standard issued, AS NZS 2918 2018, but this has not been stated in the building code, therefore it is not current. So currently for all installations and compliance, we refer to the old standard only. The new standard, when it gets stated, will include some quite big changes to the way wood fires can be installed and tested. When this happens, we'll run another training. But for now, the document has been out since 2018 and is still not stated into the building code. The picture shows a Warmington Studio Compact set up in the test rig with the thermocouples in place on the floor and the wall, you can see there, to measure heat. The thermocouples are placed on the ceiling, walls, and floor to measure the temperatures at different distances to measure where the safe heat zone is. All appliances in Australia and New Zealand are tested with soft pine wood, which has to be to a regulated size and moisture content. So the published heat outputs in all specifications, if tested to 2918, are with pine. So as soon as you start burning hardwood in your fireplace, you will get more heat output than what is recorded. Safety testing heat shields. So this is for ceilings. Heat shields are used when you cannot install the appliance to the tested clearances as published by the manufacturer. There are different requirements for heat shields based on the heat output of the fireplace and the clearance you want to achieve. A heat shield is something non-combustible over your combustible material, spaced off by ceramic washers to the dimensions as calculated in your workings. So this example shown here is straight from 2918. It shows you the air gap and it shows you the clearance factor. And we're going to show you an example of how to work out a ceiling heat shield. This slide shows you the basic principle of how we work out what is required for a ceiling heat shield. So working out the size of the heat shield using the 2918 untested appliance requirements, we start with calculating a single layer heat shield. So we're going to use a single layer of, say, steel with an air gap of 25 mils behind it to form our ceiling heat shield. So the distance required from the top of an appliance to something combustible is 1500. We know this from the building code requirements. The clearance factor for a single layer is 0.6. So we use the distance calculation, 1500 times by 0.6. The clearance factor for this equals 900 millimeters. So the distance from the top of the fire to the heat shield can be 900 millimeters if using that heat shield spaced off by 25 mils. The heat shield has to extend from each point of the appliance, from there, front and back, protecting the combustible surface. So if you draw an arc from each top point of the firebox, 900 mils, up to wherever it intercepts something combustible, it needs to be shielded. You can see the line from the corner of the fire of 1500, and this is exactly where the heat shield needs to extend to protect it. This gives us the heat shield requirements, e.g. the widths and heights required for a ceiling heat shield. So now we're going to talk about wall heat shields. So the same thing again, we've got a graph out of 2918, which gives us the air gap, and it gives us the clearance factor, and a little example of what they talk about when they talk about heat shields. This example shows us the wall heat shield requirements. Same principle as the ceiling, but with different clearance factors. We would use a heat shield when we cannot achieve clearances needed on site. Points to note, an existing concrete structure does not automatically comply as a heat shield. You'll have to show the council there is no timber touching the concrete and there is an air gap all round that you can show the council complies. This is quite a common question as people wish to use their existing alcoves on site or remove older fireplaces. The same rules apply, that it must comply with either the manufacturer's specifications or the building code to have a council sign off and therefore be covered by the insurance policies. Where you have a wall heat shield, the air gaps are required on all sides to allow the air to move around. So if you are building a fire into an alcove, you will need to have a 12 millimeter gap on all four sides, walls, top, bottom. And if you partnered this with a ceiling heat shield, you would need to make sure the ceiling heat shield clearances are met as well separately. We always recommend doing the calculations and drawings and getting sign off from council first to show compliance before going ahead with these sorts of works. So working out the size of a heat shield using the 2918 tested appliance requirements, we start with calculating a single layer heat shield. So we're going to use a single layer of, say, steel again, with an air gap of 12 millimeters behind it, to form our wall heat shield. So the distance required from the top of the appliance, from the rear of the appliance, sorry, to something combustible is 300 mils, as shown here. We know this from the manufacturer's specifications. The clearance factor for a single layer is 0.4. So we use the distance calculation. 300 times 0.4 equals 120. So the distance from the side or the rear of the fire to combustible material can be 120. If using that heat shield spaced off at 12 millimeter, the heat shield has to extend from each point of the appliance, protecting the combustible surface. So each side or part of the fire to wherever it intercepts something combustible, it needs to be shielded a distance of 300 millimeters. You can see the line from the back of the fire of 300 mils. This is where the heat shield needs to extend to cover combustible material. This is from every point of the fireplace. This gives us a heat shield requirements, the width and heights required for a wall heat shield. There are some products on the market that have been tested to comply with AS/NZS 2918. James Hardie Villa board at 9mm has been tested, and they have a very helpful guide online which shows the layout and clearance factors if you're using their product. They quite clearly show the requirement and air gaps to make their tested heat shields work. So they have a table here with clearance factors, and they have a little drawing example which shows those the material spaced off the wall around a appliance. Flue exits. This is an example of the current 2918 standard in relation to flue clearances. On the left, we have the current standard, which is 3 meters radial clearance to another building, structure, or large trees. On the right, we have the proposed new standard, which will be 6 meters radial clearance to a building, structure, or large trees. This will impact the flue heights. We will have install and the bracing requirements as well. We'll also need to take into account how the chimney is cleaned and accessed. Downdraft and flue systems. Good flue design starts with looking at the following. If the wind zone is high or coastal, you will need to think about wind noise. Structural support for the flue, as a rule of thumb, we say no more than 2 meters unsupported, also downdraft. Medium wind zone still occurs these same issues in most cases, and then low wind zone, most standard installation details will suffice. In a downdraft situation, you can see the air gets trapped on the pictures to the left, and as the flue system is just a hollow pipe, the pressure will stop the hot smoke being able to naturally draw away, therefore often pushing the smoke back into the room. The fire also has to be hot to naturally draw, so making sure the user is building a hot fire to the size of the appliance is critical. Common problems that occur is when the flue is not high enough to push out of the negative pressure. A large tree has grown into the flue space, or a neighbouring building has been built. Sometimes it just comes down to topography, and there is no way to tell how the fire will work in that exact position until it is installed. The only way to truly reduce wind noise and downdraft is to use a chimney pot or a louver box installation around it. Downdraft design corrections. This diagram shows an example of the flue system being designed high enough to push out of the downdraft area around the house. There are a few good methods to flue design we can look at. Ensuring that the flue system is sized correctly for the appliance, extending the flue into a region of undisturbed airflow. This is the most important and successful corrective measure. Providing an outside source of combustion air to the compliance, ensuring the flue is not being overcooled, removing any causes of negative pressure within the building, such as extract fans, fitting a suitable cowling. So as you can see, we have extended the flue above the downdraft so the flue can draw well naturally. Wetbacks come in various sizes and heat outputs. Each manufacturer will have different sizes and requirements linked to each wetback and the fire and cylinder they are connected to. Wetbacks are usually classed as either boosters, up to 1.5 kilowatts, or boilers, over 1.5 kilowatts. See examples shown here. Wetbacks can provide the client with an efficient way to reduce their power bill and utilise the heat their fire is already creating. Wetbacks can be retrofitted to all Wilmington freestanding fireplaces. You will need to check the cylinder can have a wetback though as well. You will need to check to make sure it does not change the clean air requirements. Wetback installation guide. A wetback should be sized in according to the cylinder they are connecting it to. This diagram shows an example of wetback installations. It is important to note when you are designing the layout of a building to take into consideration the distances and locations of the wood burner to the cylinder to achieve the best output for the homeowner. You can see the good and bad points of the examples. On the right, you can see we want gentle pipe bends to the cylinder and the cylinder to be higher than the wetback, with the pipe work no longer than 10 metres, including the return length. This means, in principle, the cylinder needs to be quite close to the firebox. This may alter your layout and cylinder size depending on the size of the house and the usage demands. All of these things need to be considered to have a good working system in the home. Rinnai has a guide for its cylinders and what size wetback should be used and recovery rates. When fires have a wetback installed, it affects the heat output and the efficiency. Therefore, you'll need to check with the manufacturer if the fireplace is still clean air approved with a wetback installed. So as you can see from the graph, we have the size of the cylinder across the top here. Which you would have established based on the usage for the home already. And then down the left-hand side, we have the wetback kilowatts output. Then we follow the line across to see how long it will take for the cylinder to come to temperature and the recovery rate. We will send out a link to the Rinnai cylinder document that has this graph in it. We also have engineers available within Rinnai who can advise on complex situations around cylinders and wetbacks, but your plumber will be able to advise on most situations and what he would like to install based on your location and usage. All wood fire installations should only be carried out by NZHHA SFAIT installer. This means they have completed a course in installation requirements and understand the current building code requirements for New Zealand. They have sat an assessment and passed. All wood fires require chimney sweeping annually or more frequently if required. This is based on how much the appliance is used, the type of wood, and the external air temperature. It is a requirement for your insurance company to have your flue swept annually, and the chimney sweep needs to be able to provide an insurance certificate to say the appliance is fit for use and it has been swept. At this point, your chimney sweep will let you know if there are any worn parts of the fire that might need replacing as well. Flues in colder temperatures can build up creosote inside the flue system faster due to the external cooling of the outer liners as the air temperature is lower. So in some colder parts in New Zealand, people may need to get their flue swept in the middle of winter. Some types of wood leave more residue in the flue system as well, therefore these need cleaning more often. Chimney fires start when the flue has not been swept as required. Chimney fires also happen if the flue sized for the fire is not adequate. Example, someone has designed a fire and not calculated the draw and the volume of gases, therefore the fire cannot operate well. Also, there is also a chance of something getting stuck in the flue, like a bird's nest or similar, which can start a fire. Chimney fires are preventable if you maintain and look after your fireplace. Each manufacturer will have a set of requirements for their fireplace, but all wood fires have the same basic guidelines. Keeping your fireplace swept and maintained will prolong its life as well and keep it burning efficiently. Also, when you are designing a house with a fire, it might be important to note in the design how a chimney sweep will get access to the cowl, the same way you would have to allow access to an air conditioning unit for maintenance. Each wood fire will have consumable parts that will need replacing over time. Your chimney sweep will be able to advise when something needs replacing. The fireplace manufacturer will have their list of items that are covered by a warranty when the fireplace is purchased. Many fires have consumable parts of the fireplace, which will need replacing over time. These will not typically be covered by a warranty. Most fires have a tested and approved flue system to go with their fireplaces. Some fires will void their warranty if the flue system specified is not used. You cannot typically swap a standard flue system for, let's say, an eco-flue system, because these work completely differently to the flue system tested with the fire. It is best to buy the fire and the flue system from the same manufacturer to ensure everything is tested and complied together. New Zealand Home Heating Association. The association is dedicated to providing the solid fuel home heating industry with professional development, advocacy and advice for the purpose of promoting renewable and sustainable sources of energy. They have lots of good tools and advice on their website, and people who become members can get support when needed from them. This is also where you can go to see who is a registered installer, and for wood and gas appliances, also chimney sweeps in your area. They run courses throughout the country, which you can attend to get a better understanding on the requirements for fireplaces. Ormington Fires is still manufacturing fires as they were previously before Rinnai brought the company. We have staff available to help with all questions and markups as required. You can send through your plans and designs to us and we can advise on what is required on site.
Right, thank you very much, Rach, for the very informative presentation. Now it's Q&A time. We've also put up the contact details of our specification team at Rinnai. Please feel free to get in touch if you have more questions about the webinar or require assistance for specific projects. Also, a reminder to please contact us if you're interested in morning tea presentations or a quick catch-up on product updates. Our Wilmington lead design and test engineer, Oyston, has also joined us for Q&A. Well, we can't see him in the camera just now. Oh, there you go. There you are, Oyston. Thank you for joining us. Now, here are some questions we received prior to the webinar, so let's start with these. First one, can you install a wood burner into a tiny home?
Thanks, Alice. Yes, you can. You will still need to comply with whatever council requirements are required based on the site location and the area, and meet the clearances to combustible materials as stated in the specifications.
Oh, and the second one, why do you need a Hebel when you have already got a concrete surround?
When a fire has been tested in a Hebel heat cell, it is because the fire generates too much heat to be installed in any other way. Warmington specifications show two different installation methods, either in timber or concrete. When it is installed in a concrete surround, the concrete becomes the heat cell. Therefore, no timber can touch the heat cell unless you can show clearances achieved as per 2918 heat shield clearances, as we discussed earlier. So as a rule of thumb, it is either the Hebel is the heat cell or the concrete is the heat cell.
Thank you, Rach. We've got a question from Haran. How can you cook inside of a wood burner? Do you need a special cooker or anything else? As all
So
plastic will be
Warmington,
melted down and metals will get black stains.
okay, so Warmington has a range of ovens. So we have the Cadrona cooker and we have the studio ovens. So if I take you back to this slide here. So it's actually, we have a wood fire box at the top, and then in the bottom here, there's actually an oven. And so how this works is the wood firebox is its own cavity inside the fire, and then it has a secondary skin. So the outer skin of the fire, there's actually an air gap. And what happens is when you light the fire, there's a damper control on the right-hand side of these fires, which you pull back, and that allows the fire to light and the gases to travel up the flue. Once your fire is well lit and established, you pull the lever forward, which stops the gases going up the flue and pushes the heat down the side and into the oven. So all the Warmington ovens have a thermostat inside them, and they also have a damper control. So even if you're not cooking in the fire, you're using the oven to heat your home. So the cooking is done in a completely separate cavity, and this is a closed cavity, so none of the ash can go down and come into the oven. It just heats the walls of the oven, and the ash travels down this little ash pan area at the bottom, in both the studio and the Cadrona cooker.
Great, thank you. And the next one is with a freestanding internal wood fire with an exposed flue in a room with a racking skillion roof, what does the flue penetration detail look like?
So we have a range of freestanding flue systems. So you can have a trim plate around, it depends where it terminates. If it obviously cannot terminate directly through the ridge, it's obviously got to have a bend if the ridge is going through and it's in the middle. But you can have a sloped ceiling plate required. There is some 2918 calculations we'll do to make sure that the distance from the flue to the combustible material, it is effectively a heat shield, and we extend the ceiling plate to make sure that distance is correct. The other option is you can drop the liners down through the sarked ceiling to once again, the acceptable distance from the exposed flue to the ceiling. I think that's the answer, yep.
Can a wood fire be used as a heat source in a rental property and meet the healthy homes requirements?
Yes, yes. So you have to do, you have to do all the calculations to do with the healthy home. But yes, if you know the kilowatts of the fire, that can definitely be brought in as your calculations, the same way that you would look at your heat pump. If your heat pump had a 5.5 kilowatt heat output and you know the studio is tested at 7.9, then you just substitute the appliance.
Thank you. And is fire installation deemed to be restricted building work under New Zealand Building Code?
Not that I know of. We recommend to use an NZHHA installer because we know that they've done some sort of training, the same as you'd use a registered plumber or registered electrician. In Auckland Council, they have a list of registered installers that have done their course. So it means if you install, say, a studio fire in Auckland, that installer, if you use one that's done the Auckland Council list, he can sign off the PS3 and send it in. The council never have to come and inspect it. So my understanding is I've never had the question of, is it a restricted building item? The most common question is the inspector will say, this is not as per the specification. How do you plan to comply? And then they'll come back to the manufacturer and say to us, can you sign this off? And we'll say, no, because it's not a tested installation, but here is how it complies with the building code, which is 2918, which are those what we talked about before. And we will help the installer on site show compliance with 2918, and then he will issue the PS3 to the council. So it's never been raised that the building consent part is restricted building work as such, unless it would maybe be a council issue to do with clean air requirements, but I've not had that question either.
Great. Next one. When a wood burner uses external air as secondary air intake, would it lower down the heat generated from the burner?
You
Yeah. Not necessarily, because when you take secondary air from the room, that air needs to come from somewhere. It's not going to just magically appear. So the air needs to be taken from outside anyway, so you don't get a negative pressure. So the air that comes into the fire is going to be a little bit colder when you do secondary, but the total sum of the heat output is going to be the same because you're not taking the cold air from the room.
Thank you, Oyston. Last two questions. So in the JH clearance, it shows the battens running from top to bottom. Would this not stop the circulating air?
So I'm not sure which one we're talking
that's
about.
the James Hardy clearance.
Yes, the James Hardy clearance.
Okay. It would, but because this has been specified, when it's been tested without an air gap. So it's a unique installation for that board without an air gap that has been tested. And they've been tested to the New Zealand standard. So that's why it complies with whatever the installation inspector is for that company, because they've been tested in this unique situation without an air gap.
Oh, sorry, we just had an influx of questions. Might have to, because of time, we might go for the last one. Are there any fires now that draw air through a double flue for passive house airtight construction?
Yes, there are some fireplaces that do that. Warmington does not have any appliances that has been tested with a second flue skin that does that, but some of the other manufacturers do have that.
Okay, great. Maybe one last one. Are there any fires now? Oh, sorry. If the wood burner is on the ground floor and flues goes through first floor hot water cylinder cupboard, what shields should be used in the cupboard?
You wouldn't need any specifically different covers for that case. When we do our single lining, usually if it's more than 4.8 meters, we recommend having a double lined flue. So when we go to a second story, we always recommend having a flue, a baffle, and a liner. And both of those are spaced 25 mil each upsize up. So when you do the double to second story installation, we always have a double lined flue system.
Great, thank you very much. And that's all the questions. So I've also posted a survey link in chat for today's webinar, which only takes 1 minute to complete. We're very keen to know the topics that you'd like to hear from Rinnai and your feedback so we can make these webinars better for you. It's also a way of us knowing that you've attended today's webinar. Thank you very much, Rachel Lane and Oystein. Now, our next webinar of the CPD series is on outdoor wood burners on the 29th of August. This will be part 2 of the wood burner series, where we'll talk about the types of outdoor wood burners, styles and designs, compliance and regulations such as the NES regulations, Clean Air Requirements, Treaty of Waitangi Act, 2918 requirements, and things to remember when specifying outdoor wood burners. Thank you very much, everyone, for your attendance and participation today. Hopefully, you now have a better understanding on indoor wood burners and more options for you and your clients after today's webinar. Thank you again. See you next time. Mā te wā. First.